Symmetric Key Cryptography by Sammy, Nina, Amanda, Jack. Info for Technology 102. So you've all heard of symmetry, which is exactly similar parts facing each other or around an axis. So if you take these visual representations, you'll see it's kind of like dividing them in half. You get the point. And you know what keys are, whether you think of an answer key, an actual key, keys on a piano, or a keyboard on a computer. At this point, you should be familiar with cryptography, and that is the method of protecting information and communication through the use of code. Only for whom the information is intended for can read and process the information. So what is symmetric key cryptography? By definition, it is a type of encryption where only one key is used to both encrypt and decrypt electronic information. So to get an idea, here you have your entity or plain text, which is the piece of data being encoded. And it is being exchanged, and after the encryption, it is used in the decryption process to get it back to its original form. So what does this type of encryption need to work? It requires the user to know which computers will be talking to each other in order to install the key. It is important to know that each computer has its own secret code that it can use to encrypt information even before it is sent over to another computer. Basically, in order to decode the information, both computers must have the same key and it must remain secret. Say, if someone were to decrypt the message, there would be a traffic between communicating parties, and that would cause a lot of flaws in the system. So now that we know what this encryption needs to work, now it's time to talk about how it actually works. Symmetric key cryptography works by the use of algorithms. Data is converted to a form that cannot be understood by anyone who does not possess the secret key to encrypt it. When the recipient has the message, the algorithm reverses the action so that it is back to the original understandable form. This key could be specific or it can be randomized. Let's look at an analogy comparing symmetric key cryptography to everyday life. So let's say you're sitting in class and you want to pass your friend a note making plans after school instead of listening to your professor talk about Shakespeare. You write your note and where you substitute all of the A's for Z's, B's for Y's, C's for X's, and so on. Each letter corresponds to the alphabet backwards. Your one friend knows this code and can read and decode the message, but everyone else in the room is simply left confused and doesn't get what is being said in the message. Because you and your friend are the only people in the room that know the code, you are the only people that can send messages to each other back and forth. Your friend can either decode the message and send back the original or send back a new message. Simply, having the key is essential in the encryption process, but in this case, it's essential for communicating with your friend, leaving everyone else confused. On a smaller scale, you can think about having an inside joke with your friend, and when you think of it or talk about it, you can make jokes back and forth, and only you two understand and communicate the message, but everyone else is wondering what you're talking about. Looking at important principles, and specifically math principles, we can look at two variants of key algorithms. We have block ciphers and stream ciphers. Block ciphers are groups of bits and fixed block sizes in multiples of 8, and that is 64, 128, and so on. Stream ciphers, however, operate on single bits of data. They have a disadvantage, however. That is that their dependence is on random quality of number generators that generate key streaming. There are specific circumstances to use each. Looking deeper into algorithms of symmetric cryptography, we have one-time pads. This is the kind to completely hide plain text and has no chance of being recovered by brute force. Random data may only be used once, and the advantage of this is that almost all computer systems can use and operate this efficiently. Here you have someone with a plain text and a one-time pad being used to create a ciphertext. Then it goes to the internet, where it goes back to the other computer in the cipher message, where a one-time pad is used again to get back the original message. A key takeaway of one-time pads is that it can't be recovered by brute force, and basically all computers have it. Next we have data encryption standard. This has an original use with 64-bit keys, but because some key bits are used for key integrity checks, only 56 are actually used for encryption and decryption. DES, or Data Encryption Standard, is actually no longer used because it is insecure and can be broken with brute force in less than a day. Last, we have Advanced Encryption Standard, which is the most popular and widely adopted symmetric encryption algorithm. It is 6 times faster than Data Encryption Standard and uses less power. It has many features that make it unique amongst any other algorithm. There are 5 features that make it different. First, we have Symmetric Key Symmetric Block Cipher. Then we have 128-bit data. We also have the characteristic that AES is stronger and faster than DES. We have an idea of its full specification and design details. Lastly, we have software that can be implemented in various computer systems. Looking closer at AES. Each round of AES is comprised of 4 sub-processes. In round 1, you have the cipher key, and you have your plain text. When you add a round key, you get sub-bytes, shift rows, mixed columns, add rows, all represented in the diagram. You start with 16 input bytes substituted in a matrix of 4 columns and 4 rows. In the rows, each shift to the left, those that fall off are reinserted to the right. Each row, however, has its own properties. The first row is not shifted at all. The second row is shifted by 1 byte, position left. The third row is shifted 2 positions left, and the fourth row is shifted 3 positions left. The result is now a new matrix of the same 16 bytes but shifted. The columns, however, follow a different sequence. Each column is transformed by mathematical function. It takes an input of 4 bytes of one column and outputs 4 completely new bytes, and they replace the original column. The result is another new matrix of 16 new bytes. Depending on what round of the algorithm it is, depends on how many bits or bytes it's considered. 16 bytes are now considered 128 bits. If this is the last round, the output is ciphertext. Otherwise, the 128 bits are interpreted as 16 bytes and new round continues. Looking at decryption is similar but in reverse order. Here you add round keys first, then you mix the columns, then shift rows, and then byte substitutions. So who uses symmetric key cryptography and what for? It is used for bulk encryption or encrypting large amounts of data, especially in database encryption. It is also used for payment applications, such as card transactions, and can be used to prevent identity theft or fraud charge. You can also use this type of encryption for validation to confirm a sender of a message's identity. Lastly, it can be used for random number generating or hashing. That being said, it is used for banking security and corporate reasons. When you think of symmetric key cryptography, the main thing that should come to mind is that it enhances security and user privacy. When you think of this type of encryption, it is important to remember that it is used on a large scale. That means it isn't typically used by you and me because it is impossible to conduct this type of encryption manually. While beneficial to keeping our safety, it does have its drawbacks. Information can get leaked and be exposed to third parties. When this data is released to them, they have all capability of looking at our private data. In conclusion, symmetric key encryption or cryptography is a very challenging subject to understand. With its special software, though, it can be very beneficial to our privacy and safety.